in a second. So I think we're recording. Just I want to say welcome everyone. This is the Kubernetes Book Club. Every Friday, same time, same place, same Slack, same CNCF. Thank you for those that are coming.
Different books, though.
And just follow the CO, the code of conduct. Suggest your attendance in the doc, the Google Doc, and if you have any news, just put them in the doc. Suggest them in the note. We'll accept them. Um, Falsa share a GitOps advanced GitOps certification from Acuity happening October 25th in Utah. And Sebi, you have another one on?
Yeah, I have just been attended the organizer committee of the Cube train for next year. KubeCon Paris. We are going to be renting a full train carriage, and we'll find sponsors, and it will be a massive fun and hopefully a great experience with lightning talks and games and probably hackathons. We've just started working on it, so please stay tuned. We'll be sending sharing more information.
Yeah, I saw that in the CNCF ambassador meeting. So I
Yeah.
added the
Oh yeah,
added
cool,
the
cool.
link,
There's
and there's the
also
channel
there's a channel as well.
in CNCF. And for those that are new to the book club, we are doing the series on the CKA, doing the book Acing the CKA, Acing the CKA exam by Chad Crower, which is here. That's I think the first series that we've seen, like the author coming to the meetup and helping host and also answer questions. So I'm super happy about that. And then today we're going to have Sevi host our section for chapter 4. So that's what we'll be discussing today. I put a link there to the live book. People can click on it, and follow along. I also put a link to the Appendix A, which has the instructions on how to create a kind cluster with multiple nodes, which I think is the first section on chapter 4. I think that's it.
Yeah. All right. Thanks for the great introduction, Carlos. So welcome everyone to the fourth chapter of Acing the CKA exam by Chad Crowell. This is my first time hosting actually the book club. So this has been going on for some time, like probably since mid-pandemic. I've attended so many of them, but first time hosting. So we are
You can say a little bit of
together.
background, Sebi, if you want. Just an intro. What do you do? Where do you work? And any
Sure.
course or that you want to promote? I don't know, like an Istio course.
Oh my, yeah, So I work at Container Solutions. I'm an engineering lead, and what Container Solutions does is we basically help customers move to cloud. We do lots of infra stuff. We are a cloud agnostic company, so we do all the clouds. And I've been working for Container Solutions for like a little over 2 years now. It's been an amazing journey for me. I also actually found out about Container Solutions through the book club. We had one attendee, Valid, who shared Container Solutions tweets about their job openings. So I think the book club is a great opportunity for us to get together, learn together, and sometimes fail together. Back in the day, we used to do the TGI Kubernetes all together. So we used to have the book club around this time on Fridays. Then right afterwards, we had most of the time Duffy Cooley or other VM folks hosting on the TGI Kubernetes, which taught me a lot as well. And so, kind of saved my sanity, the book club and TGI Kubernetes all through the pandemic. So I'm really happy to be able to give back to the community this time around. And yeah, I made amazing mates here: Eric, Carlos, Valit, many from India and from Middle Eastern area as well. So it's also great to see people grow. So yes, I have an Istio course on Code Cloud platform, which probably needs some updating as well. So we were having a chat with Chad today. It's so hard to keep everything, the codes and the whole the presentations and the labs in place. So yeah, we found a few typos in the chapters today. So I'm going to switch to the book, the chapter of today. It will be deploying applications on Kubernetes. So we've been discussing obviously the CKA content, the CKA focus on the node and administrative parts of it. And this time around, it will be the actual usage of Kubernetes, as in deploying applications. And next week, we'll have running the applications, I believe. So yeah, we're going to be shifting our focus to the workloads and scheduling part, and take a look at the details of scheduling. So what scheduling means is deploying applications, basically the ability to reserve resources from the underlying infrastructure, right? And there are many ways to deploy applications. I'll be referring to the book, the sections a lot, so it will probably be a little bit of reading as well. So the Kubernetes component that controls the whole assignment, deploying of pods to nodes is called the scheduler, right? So we'll have a few example of how to do that on for the purpose of the exam, obviously. And then we'll discuss decoupling the components like configuration or sensitive data from the pods, so we could have clean deployments. So you will have examples on creating and updating application deployments on the exam. So let's get cracking. For time management purposes, I decided to create all the YAMLs for today's chapter, but Chad obviously provided them in the book, and I think that's great. So let's try.
Let's see.
Do we have the? Yeah. So this time around, we'll try deploying. First, we'd like to understand how labels can be assigned to nodes, because that for sure might come up in the exam. Let me wait. Let me close this. Got this all here. So we have nodes. This is the command that will help you to get the labels. So I have a kind cluster with one control plane and two working nodes. And I happen to actually add the example label in here, but normally you wouldn't see that. And let's see how that could be done. So
and for people to for people to, if they want to follow along in the notes, I put the commands like create a kind cluster. It's in the book to create the config file, to create the cluster with 126 with multiple nodes, and then the Docker exec to get inside the cluster like Sevi it is, and then to set up the autocomplete. With those three things, you should be at the same level of Sevi.
Yeah. Sorry, I just skipped that, but that's essential, of course. Okay. So now this is the command that will actually help you label a node. Let me paste that. We can actually, I can try having something else here. This time around, I'm going to actually label the second node because I had already done this for the session. So let's see. Yeah. Let's see. So I'd like to have all the applications here. Let's say super unrealistic maybe, but okay. So when you run this command, you'll see my new label here, but also the one from Chad's example. Let's see. Now we can actually ask Kubernetes scheduler to get our pod onto a node that is labeled with disk equals SSD. So let's see how we can do that. So I have this here, but for the example, I'm going to okay, wait, I missed. Okay, maybe I should just do that because time's running out, right? I'm already around 20. So when you're creating a pod, obviously you will be able to add labels on it. So
You're looking for line 13, the node selector?
yes, yeah.
Okay.
Sorry.
Yep.
I was lost.
And just to be sure, you didn't label it with this type SSD. You label it with something else. So you may want to label it with this type SSD if you want to do it with SSD.
Yeah, this will help us deploy our pod onto kind worker, but I can actually change this.
Yep.
But the syntax.
You want it to land on the worker 2.
Yes. Now this will be going to worker 2. So I'm going to use the apply command. Let's see where pods are. So sorry, I don't probably need to do that.
Do -O wide, and I'll give you the worker. O wide, yeah.
Wait, SSD pod. Yeah.
Yep.
Yeah, if you can see it, you can see it's landed on a specific worker node. So you can use this for different purposes. This will for sure, some similar examples will come up in the exam. You can use this for a specific resource. Let's say you have your nodes are having a specific disk or a CPU, and you want this application to land on it. So that's the main purpose of being able to. Well, there might be many different reasons to be directing pods to specific nodes, right?
So I have a trivia on this one. Xavier, you can go up.
Yeah.
And the node selector line, there.
Do you need the code?
Yeah, the code. Yeah, put the code. Line 14.
Yeah.
So we have one label here, deployment type application. So this is a trivia just to make stuff interesting. What happens when I have two labels? Is this going to is the purpose of the pod that it can go to one node or another node, or is this an and or an or? If I have here, does the node has to have these two labels or just one of them?
Yes, it must be working as or, right? So it obviously, or would it expect it? Okay, I have to check. Let's see. I don't remember.
Chat, want to chime in, or Eric? Anyone?
Sorry, was dealing with something on the side. What is the question?
No selector. If you have two labels, is that an or an and? Does the
Oh, good grief.
Yeah, so I need to delete it, obviously, because some specific changes cannot be done. This will also come up in the exam as well. So if you're like updating some resources, you might not be able to update everything for a specific resource. So for example, for this, I will have to, if I'm changing labels of the node selector, I will have to delete it.
And pod are immutable, right?
Yeah.
So you have to create another one. That's the benefit of using something like deployment.
So as this is being created,
what's the status?
Oh, it's pending.
Why is pending?
Because it's an and.
It's an and. Yep, that's the answer.
You would need pod affinity for or, right?
Yeah. You have you would use match selectors where you can do this key or value in or not on. Yeah, it gets more complicated with match selectors. But continue, say, because I don't think we don't want to spend a lot of time here, but it was just a short trivia on if these labels, because usually like when you get started, the samples show you one simple example with one label, but then in real production you might deal with more labels, and you need to understand that this is an and not an or.
Yeah. I labeled the nodes.
And then how you fix it? You put the missing label in the node. Perfect. So you did the SRE part.
So I have now here both labels, and you can see my pod is already running.
Yep. So let me know if you like this type of trivias or not. But I would not do that much because I don't think we have a lot of time.
I actually have hidden something in the config maps as well. Let's see. Because I had a problem today. I had a syntax error. I had a typo error somewhere, and while I was troubleshooting it, I thought it would be helpful.
Yeah.
So
chat put a few of those on purpose on the book, so see if people can find them.
Might be fun.
Just kidding.
So if you need to schedule a pod to a specific node for some reason of the infrastructure layer, you can actually do that using node selectors. I actually have already done it. And
skip to.
Yeah, I'm gonna just try to get to the node and pod affinity part. Yeah. So we can also use these to apply affinity. It's like node selector, but a bit more expressive. And an affinity rule, will prefer a node with a label, but also accepts scheduling to another node if that node label is not present. So there is a nice example here, problem that the problem it solves is, and large Kubernetes clusters where not only pods come and go, but nodes go as well. So like what if you lose a node, right? What if you would also probably lose your labels as well? So just directing your applications by node selectors to a node, it might not be that useful in real-time scenarios. So if alienating a pod, if a node is not present, Affinity, rather than doing that, Affinity provides a more flexible rule set. So it will help us a little bit more around where we can deploy our applications, or like what type of expressions we could use. It's a bit more like, having I wouldn't say regex, but like having expressions to be able to define where they go. Let's see now where. I'm not sure if you guys can read my font though. Like, do you want me to make it a bit bigger?
Just Command plus one.
Yeah. Oh wait.
Command plus should do it, Savvy, I think. Yep.
Right. So let's see. This is the example from the book. So we can actually even use this command. Let me try that.
For the actual exam, I'd recommend utilizing your additional tab that you can have open to documentation for this.
I actually have my cheat sheet in a different screen now.
So I wouldn't recommend trying to memorize this for the exam. I think you'll waste a lot of brain space, right? So you can just copy and
dry run is your friend. So yeah.
Well, in this case, these are node affinity, anti-affinity. Those sections are difficult to generate with dry run. So what chat says correct. Like look for an example in the documentation and copy the example and then modify, adjust it. Be the fastest way for the exam.
Yeah. What would you recommend? Let's see. I was going to ask Chad, but let's have a look.
Yeah, so it will be something like this one.
Like if I was in the exam, I would be.
Yep. If I was in the exam and I had my documentation open, I would search for affinity. And it should be the first link where it says assigning pods to nodes.
Yep.
And then it's the first example of affinity.
Yeah, then you could just get everything from here and then just copy it to your terminal.
Yep. Copy the section.
Yep.
What was that? Was that a question? So
that example had the required but not the preferred. So there's actually another
different sections.
Yeah, I'm going to switch to the book example anyway. So let's read. Required during scheduling, ignored during execution. So this is a pod affinity example to get your pod to be scheduled on a node that has a Kubernetes iOS OS equals Linux label on it. So this has to be required on your node. This has to be on your node to be able to deploy this pod. But also, the same node would prefer disk type SSD label on a node, but it's not required. So this actually basically tells the whole, right, affinity rule here. So it will be a match expression with key and an operator and value. So there might come up, different operators might come up for different questions in the exam. So you might want to try these before going in. This is, I think, important.
Good question here. So, Chad, do you have preferred and required both state in the pod? Then is that valid?
So required is what's required for the pod to be scheduled, and then the preferred is based on a weighting system. So if there's no pods that have the disk type equals SSD, then it doesn't prefer that. It doesn't prefer that, therefore it'll go to one that's Kubernetes.io/OS equals Linux.
So it's meeting different criteria, right? So I'm looking for a pod that must be Linux, right? So it's OS.
Yeah.
So from all the pods that have Linux, and then the second one is like, I prefer to land on one that is Linux and SSD, but if there's another Linux that doesn't have SSD, then that's okay. But the Linux is the required. So it's the both in the same pod. That's how they work together. But they don't necessarily need to be like always present in Node Affinity. It can be one or the other or both. Yep. Go ahead. Sebi.
Okay. I'll move on a little bit faster. Oh gosh, time is running. Okay. So the interpod affinity is a little bit different than Node Affinity itself. So let's see what I have an example here. Oh, I don't have it. So all nodes in our cluster have Kubernetes IO hostname. So this will match all of them, right? With this topology key.
Make it a little bit bigger. Can you do Command plus?
Wait.
Yeah, so pod affinity in a nutshell is the scheduling of a pod that has already different pods already scheduled to that node. So let's say you're going to schedule your pod. I can say, hey, I want to schedule this pod to a node that already has another pod running on it. And the example in the book was Nginx. So I prefer a node that has Nginx already running on it. And then anti-affinity is the opposite.
My question is like that. Obviously, there would be cases, but I kind of find myself trying to do sidecar container patterns like for this specific scenarios. I know, this is useful, but I usually kind of start with the container setting usually, rather than trying to have pod affinity in place. But yeah.
What do you mean by the container?
I mean, the container sidecar patterns, right? So you have multi-container patterns. Like, so I'm like, you might need different pods in a specific node, but I usually start thinking, can I put different containers in one pod? Like, I usually start thinking with that. But obviously, first.
I see. Yes, so that's correct. What Sebi said is perfectly good advice. Like, if you are designing an application that these two containers they have
to be together.
Together, then the first choice is having two containers in one pod, right? When you have then the second use case beyond that is if you cannot satisfy with that is because you may have a less number of pods and then more numbers of other ones. So for example, if you have, I'm not saying that it's a good thing to run databases on a Kubernetes, but let's say you have 3 pods that are databases, right? Three pods representing a database, like replicas, and you have 10 pods that are web services reading from that. So then you have a 10 to 3. You cannot put them together, but when you deploy the 13 pods together and you have like 25 nodes, you want to tell Kubernetes, hey, by the way, try to put a web pod with a DB pod. If you can match them like that, so at least there's a pod of web with a node together in one node, so you get performance there. The other ones will be anti-affinity because you don't want to have all the web pods in the same node. So that's where anti-affinity comes in. So that's kind of like the most powerful, I would say, thing about Kubernetes is the power to influence how these containers get assigned.
Exactly.
Right there.
I'm not going to ruin the surprise by doing the exam exercises, but I think they're really good. So just make sure you guys do that. Now moving on to the Helm section. This is we'll be briefly touching Helm here. So there are different ways to configure applications in or deploying applications Kubernetes, but it's really hard to configure everything, be on top of all the deployments and everything, like all the other components that you would need, your application would need. So it's a difficult thing. So Helm is going to come to the rescue here. So also you would need to get everything working together, right? So Helm is the package manager of Kubernetes, and it will be the part of exam, and we need to understand how to use it and how to actually, also, it's in real life scenarios. Helm is perfect for lots of problems, so you would need it. So I have Helm in my local machine. So Helm list, let's say. Oh, I don't have anything here.
Repo list.
Yeah, repo list. So I have HashiCorp and MetalLB repos here. But in the book, you would see how to install and configure Helm. So I'm going to move a little bit faster. So now one of the important things you need to do is to add a repository so you can use the Helm charts in there. Helm charts are the sum of all the configurations you would need in an application, or however you want to say it. So let's see. I have the MetalLB here. Our example would be around that. But the way to do it, the way to add the repo, is to use this command here. Let me add it again. So it says it's already there. And so now we're going to do some templating. It will be through the values file. And basically, we're going to be passing the values we would need to be able to use our Helm charts. So this is the example values YAML for MetalLB Helm chart. But to be able to use that, which will help you deploy this, you have to find kind Docker bridge CIDR. So I don't have Docker on my local, I have Podman. So I found the command that would actually be needed to get the same. Oops, let me share it in the chat. And for this example, you would need an address space, right? Let's see. So So this is my values YAML. I basically found my local machine's address space and then tweaked the values YAML to be able to deploy this Helm chart. And yeah, let's see, but you need to pass the values YAML to your Helm install command. Okay, because it's different. I have added these here. Okay, now MetalLB is running in the cluster. I guess that was the end of it, right? Let's see if Helm can list this. Yeah, now MetalLB has been deployed.
Yeah, this is Helm chat. Helm is mentioned in the requirements now. Remember CKA like 3 years ago, Helm was not part of CKA. Is it part now?
In the curriculum, it says awareness of manifest management and common templating tools.
Ah.
So it doesn't call out Helm specifically, but I mean, what else do you use? You know,
Q customize like non-Helm. I'm just kidding.
Okay, I'm not going to throw gas into this discussion, but yeah, it's. I also don't remember I got Helm questions the last time I took it. It was a year ago. But
it's good to have it, and also like in terms of learning, one thing that I will add about Helm is Helm. I mean the Helm project and some vendors, right? We're trying to put Helm charts in OCI registries, Docker registries, instead of having HTTP repos. That's becoming more popular lately as people are putting their Helm charts in Docker registry is easy to manage. And just remember that when you use OCI, there's no need to do repo add because you're not adding a repo. You can, when you deploy a Helm chart through a Docker registry, basically is like a representation of one repository. So there's no like repo add. Just specify the URL when you deploy, and then that should do it, and also authentication to it.
So this is the pod metadata section. We'll basically be doing lots of tweaking on the pod spec. So we'll discuss how to set up resource requests and limits. We'll have examples of multi-container pods, and then having config maps and using config maps and secrets to pass different types of data into our pods would be in this section. So also now you would need to, every time you configure an application, it's wise to consider the underlying infrastructure. So in the resource request and limit section, we'll talk about how a pod could ask for resources from the underlying infrastructure. It could be in terms of, it could be CPUs, it could be RAMs, but all of them can be applied. And the good thing about it is, like, you may have a critical application and you may just want to just allow it to use as much as resource as possible, whereas your non-critical applications, if they are okay to just not run, you can just limit, or you can even test if the resource usage is a blocker here. Like, imagine your pod is failing constantly and you want to understand the reason, and sometimes it's like a pod sucking all the resources on the node, right? Sometimes you may want to test this by using resource limits and requests as well. So it's a nice way to also, I think, I used it in the past as a troubleshooting way. Yeah. So let's see. I'm going to close these and okay, let's see this one. But also, I think, yeah, there will be more from in the book about resource limits and requests. So 1000 M would be the same as 1 CPU because it's the values are on millicores. So in that sense, fractional requests are also allowed. So you can ask for a 0.5 CPU because it would equal 500 M. And then memory is measured in megabytes, which is, yeah, a measurement based on powers of 2. So let's see. Oh, we don't have a full example on this. No? Oh, okay, there. Do you want me to move forward or just try this one? I'm going to...
So I have a trivia. Another trivia to make it fun. And you show the CPU limits where it has the numbers. So what's different between all these numbers with CPU 2 from the other ones? The one that says 2.
It doesn't have quotes around it. Yeah.
So it's an integer or a string?
It's an integer.
Is that a bad thing or a good thing?
Well, I would take it as a good thing, but how do you mean bad or good?
Well, the Kubernetes has types and has CRDs, and in the specification you say it's a REST API. So if the REST API says give me a string, why would someone give a int? Would the API barf and say like, this is not a string, give me back a string? I asked for a string and you give me an int. So this has the potential or not the potential of having an error when you apply it. So as a, not saying that this is going to fail, it works because a lot of people don't know or don't care or like, right? So a 2 is a 2, but as a general rule, always follow the spec. So at least my rule for limits resources, I always make them string. Because sometimes also there's things like Argo CD or Customize that are rendering and checking, like if you pass the thing that you ask is the thing that you desire. So it could be that you send 2, and if you ask back for what value is in the etcd, it will say string 2, and that's different from the desired state that is in Git.
Yeah.
So that's just a trivia. So Chad, any comments? You did it on purpose?
That was a trick. No. Yeah, I would agree. Yeah, if it's going to be always expecting a string. So I looked in documentation real quick and saw that all the values in documentation will be are listed as strings as well. So yeah, stick to strings for the exam.
And also another tip, if you're not sure and you don't remember and you're in the exam, the command that we have been telling you that is your friend is qexplain. So I did qexplain pod.spec, and then you start following that, right? So qexplain will tell you that is the type of a field. If you're not sure or you cannot find it in the docs, don't panic. Use explain, and that will give you the answer. So this one is a map of strings and quantity. So
yeah, I actually just saw that once you asked. I didn't see it before. Yeah.
So sorry for the interruption.
No, I'm not going to type it.
No, just continue
but
the
I'm
next
going
section.
to explain the request and limit difference. So limit is the maximum this pod could use, whereas request is the minimum this pod would require. So you can use either both of the CPU or memory, or one of them in these in the pod spec, I would say. So you don't have to all the time define the CPU requirements or request or CPU limit, or as well memory as well. So I'm going.
One thing, but it's one thing to mention here that is something good to remember is HPA, horizontal pod autoscaler. When you configure the horizontal pod autoscaler, saying when the CPU is this percentage, create me a new pod, or the memory is at this percentage, create me a new pod. What value does it uses? It uses requests or it uses limits for HPA? It's a quick trivia before we continue.
It would be requests. Requests is a scheduling concern.
Yep. And most people get confused and they think it's limit.
Limits is more of a security concern from my point of view, from what we talk about.
Fairness.
You limit a process, it can go start mining Bitcoin or do whatever it wants if it were to be exploited. Yep. Not to mention it could bring out of memory your system.
Mm-hmm.
Yeah, OOM.
I'm going to move on to multi-container pods. So sometimes, you might need more containers in one single pod for specific use cases, which is very common in the Kubernetes world. So I just to summarize the whole thing, I just wrote down this thing in my notes. So we have 4 patterns. First one is sidecar pattern. If you need your application and some additional functionality next to it, this would be the sidecar pattern. So you could have your main container and a logging or I don't know, proxying container next to it. That would be the sidecar pattern. Then the adapter pattern is used for, actually it must be in the docs as well, right? Container. Adapter pattern is for standardizing output values. If you need a specific, like it's kind of helping your main application to adapt its outputs, let's say, to the outer world. And then ambassador pattern is it acts, the second container acts like intermediary container, let's say. It's like quite similar to the sidecar pattern, I would say. Then init container pattern, which I think we'll have our first example for, is you might need sometimes before running your main container, you might need some setting up tasks before your main container starts running. So that's when you need an init container.
Can I mention something real
I'm
quick?
almost certain that it would be here, but yeah. Let's see.
Can I mention something while you're doing that?
Yeah. Oh, please. Oh.
Can you hear me?
Yes, please do, Chad. Sorry. Yeah.
Oh, yeah. So the exam, as of just a few weeks ago, or maybe it was last week, was updated to use 1.28, the version of Kubernetes. So
yeah, you mentioned that the other day. Yeah.
You're mentioning, while we're on the subject of init containers, so you can now, as a sidecar pattern, you can create an init container that will serve as a sidecar. How you do that is you set the restart always, set that to true. restart. I'm drawing a blank right now, but it's yeah. So you create an init container, and then by setting the always restart to true,
right.
you can effectively have that pod or have that container act as a sidecar. So for the exam, I wouldn't necessarily rule out the some questions on the exam. So like if I were just to guess, the question on the exam may be, implement a sidecar pattern using init container, set your image to blah, blah, blah. And, but when you see the keywords init container and sidecar together on the exam, that's how you know to use this new 1.28 feature. So just look out for that.
Okay. So we'll ask, because I haven't been following about the 1.28 changes. So it's like having an init container always running and not like finishing and then your main container keeps running, right?
Right. Yeah. Restart policy. That's what I was trying to think of before.
Yeah. It's a good way that they implemented it. The way they implemented it was very clever. I thought
that's like nothing super new, but yeah, I totally get that. It's very clever. Yeah.
The only thing is it's a feature gate, and it's the first release that has that feature. So I think it would be very mean if they include it in 128 CKA. But yeah, this is a good resource. So just remember, restart policy always not on the pod spec, right? It's on the init containers.
Has the you said exam is also changed to the 1.28, right?
Right.
Yeah. Okay. Just yesterday, one of our colleagues got CKA. I'm just going to ask her behind the scene if she saw this.
Well, they have a pool of questions, right? So not everyone gets the same question.
Yeah, but I'm just curious. Okay. So what time is it? Oh gosh, 3 minutes. So where are we? The book. Yeah. So this was the example I couldn't get working, but I also didn't have the time to troubleshoot it. Is this that one? Yeah, I reckon.
So the benefit to having multiple containers in a pod is they share the same network namespace, right? And they share the same volume.
Yeah.
So on the exam, I would look out for, and a question on the exam may be, create a pod with multiple containers where they share, where one container will create logs that another container will consume.
Yep.
By the way, I have a sleepover party with 3 girls, so I'm sorry about the background noise.
Oh, there's no noise. It's fine.
Yeah, I don't hear anything, so you're good.
Good filtering then. Okay. So basically, in the multi-container pattern, you would see in the pod spec, you would see under containers more than one image, more than one containers, right? Let's see why this doesn't have any other. Good one. Let's switch. Yeah, I just still wanted to show the spec. So this has init containers, but it doesn't have to be. It's for a specific purpose, right? Your init container runs, either stays alive now or dies, and then your actual main container runs. So you would, under the spec, you would see more than one container section.
Yeah, in this case, it's checking to see if this service named init service or init-svc is created before allowing that other container to start.
Yeah. Yeah, yes, this was the one I couldn't get working. I just created the service as well, but there's something weird. So let's go to the sidecar. So basically, let's switch to this. So as you can see, we have one section for one of the containers and another one. So first, I wouldn't say first because there are two containers here. It's a sidecar pattern. It's not because of the name. It's just like two containers or more than one containers are running next to each other. That's why I'm calling it sidecar. It's an image of it's a BusyBox image here, and it's an Nginx image here, and both of them have volume mounts as well. And so it's really helpful to have sometimes more than one containers for many different purposes. For example, in my Istio training, you would have an Envoy container running next to your Istio all the time. But sometimes I've seen this in different product. I wouldn't say product, but in different companies, it gets so it is so easy to share resources like that within a pod. People start putting too many containers in one pod, so that becomes a big, massive, like little and how do you say it? I forgot the name. Anyway, a big, massive application in just trying to run in one container.
That's the monolith pod pattern?
Sorry?
It's the monolith pod pattern.
Yeah, monolith pod. Yes, thank you. Just lost my train of thought. Init containers have a specific way to define it. You would have to say init containers, and they just run and die and do whatever it at first. For this, I don't know why I just couldn't get it working. We'll have a look at it again. But this example would need your init container to run and find the init service, and then
yeah, for this, good. I'm glad you brought this up because we should be using BusyBox 1.28. So I'm not sure why I put 1.35 in there, but that image it doesn't.
You want me to try it now?
Resolve.
I'll just wait.
Sure.
I have it here. Yeah, 28. You said, right?
Yeah. What's the issue?
It's the issue with the image. It doesn't resolve. It doesn't do the NS lookup. So it's a DNS issue.
Because it doesn't have NS lookup inside?
Right.
Oh.
Great to have the author, yeah. Okay. I'll probably have the service already though. Yeah.
I'm trying.
Okay. Wait, I need the service first to get so you guys can see. And yeah, really. Which was it? Yeah. Okay, so this would require you to create your init service first. So I'm first going to create the pod with the init container, but it won't be able. Oh. Okay. It won't be able to find the service. Okay. Or Why don't we talk about namespaces already? Have we talked about namespaces? I can't remember. No, right?
No, we haven't talked about namespaces.
Okay, probably later on. Okay, going back. Yes. Now it's hanging in there, right? Because it still needs the init container to finish its job, but for init container to finish its job, it has to find the init service, but I don't have the init service. So now I'm going to create the service, a service with this name. Oops. Ooh. Okay, I probably should find the YAML for that, right? Yeah, cluster IP, yeah, TCP/80. Okay. Now, but that would take some time, right? Oh no.
It went fast for me. Went fast. I don't know why. Chad, you mentioned that it takes minutes for you. 7 minutes, you said.
Yeah, 7 minutes. Yeah, but
yeah, for me, it was in seconds.
I also got it.
Probably because I was using that other image.
Oh, okay.
Okay.
So
add it to the errata again.
Oh, this one, right? Okay. Why? Can I ask a question? Why would Manning Livebook have? Oh, it's deleting highlights. Sorry, it's like deleting the line. Yeah, just doesn't make sense. So let's move on to config maps and secrets. Would I be able to squeeze that in? But we're already 7 minutes over. What do you think? Should I just do this and stop, maybe?
Yeah, just go for it.
Yeah, we have folks still here, so finish.
Cool.
And this is recorded, so I don't have a meeting.
Okay, cool. If you guys have to leave, that's also cool.
Yeah, I'm good.
So
Just spend 5 minutes on config map and secrets.
So pod, we tested how to request CPU and memory. Now we can talk about using config maps, which is like config maps can be used to pass configuration into your applications, into your pods. Just any random stuff you would need, or it's quite fun to play with config maps, actually, if you especially have a nice container that are using them, like even passing your I don't know, this is a cool example, background color of your web app, or whatever you would need. So there are different ways to inject it into a pod. It could either be using an environment variable or a value mounted to a container, or and you can also create config maps from using different ways, like from literal values, from using a single file, or from using multiple files in a directory. This is, I think, is a very important topic for the exam. I have seen during my exam experience, I have seen plenty of questions around that. So let's see. Let's create this. This is a cool one. If I could get to my Easter eggs, if I could get my Easter eggs working, that would be fun. So, but the example in the book is, so you can have a config map like this, or you could have, let's see, yeah, you could use a multi-line value for this key as well. I already have it. No, not this one. Let's see. So yeah, this is the first example chat provider. So you can, like, if you're creating it from literal key, you would give the key value mapping here, and then by just using the dry run flag, you would be able to have it. That's very useful. Just so you would, it's nice to have it on the exam. So there is a typo here I made today, which was fun to figure out later on. That happens as well during the exam. You may do typos, so you may need to troubleshoot your own issues. So this is the multi-line config map, let's say. And now I'm going to attach this to a Redis container. I think it's helpful. It's basically this command chat put. I just extracted the YAML. got the YAML and saved it. So also it's nice that I have the coloring here. But in the exam portal, the editor would also help you, like, right? It's not a flat one with no coloring, right? It should probably have some sort of
yeah. I remember trying to set up all that spending my 10 minutes.
Yeah, it's
in
just
my terminal.
tricky to read all the indentation and everything without that. So this is the basic. This is the example from chat's command here. So I have, as you can see here, I'm going to mount this config map data using via an empty dir volume. So how am I going to do that is the volume name and the mount path name would be the same, right? They are the same, right? Okay. Yes, so here in data in the container at Redis master data will reside in an empty dir, and attached here we'll be attaching the config data. So Redis server, Redis will be using it, and we'll be Redis image, and we have Redis server command running in this. Okay, let's see if we'll be able to find my little typo, which probably is helpful when you know it's a typo. But I'll first create. This is the command I use the most during exams, like having everything in a YAML. Then applying it is super helpful, because when you make a mistake, it just is really helpful to just check the YAML afterwards. So that. So I have a config map. Let me try to get the pod as well, which is here, Redis pod. This is 9. So it's stuck at container creating.
It's creating.
No, it's not, because I know there's a problem in it.
Well, check what's going on. Do a describe.
Yeah. Scribe. Oh, sorry, P. Yeah. Let's see. That would be your best friend, the describe command, guys, because it's, yeah. So here, as you can see, Kubelet is warning us that it is not mounting this volume, and the Redis config is not found. Redis config map, sorry, Redis config map. So let's have a look why it's not there. I have this, but I want to see why it's this. Okay, let's fix the name. Wait, I don't need to fix the name, right?
Nope.
No. So what's the problem here, you think?
What's the problem? There's no config map called redis-config. I see 1, 2, 3, 4 config maps, but none of them is called Redis config.
Okay, let's check that. Delete. Okay. Okay, I have one. Let's see. What is this pod doing?
Do you need to restart the pod? That's a trivia.
Yes.
Let's see if pod tells us. Any ideas?
Oh, you have another error?
I think so.
Start the pod. Just delete the pod and recreate it.
No. There's no need for that. I don't think so.
Redis. Okay. Okay, mine is 9 Redis. All right, yeah. 9. Okay, configure. It's taking longer than before. I don't know why. For some reason. Or am I getting more impatient?
For deleting a pod, the typical time is the 30-second timeout.
Yeah.
For the kubelet, but you can do like grace period equals 0 if you want to delete stuff. In the exam, if you want to delete stuff faster, then you can put grace period 0. You want to really force it, you can do force.
Oh yeah.
Equals true.
Oh, I forgot that. Yeah.
But I would not think that you needed to delete and recreate the pod. So it's gone. You created it. And it has an error. Good. Yeah. You don't need to recreate it. It has an error. There's something wrong with it.
Yeah, I know. There is another error. Second Easter egg.
Yeah, go ahead and describe it. I think it's something, we're saying something about the volumes.
Okay. So it's config map is mapped, right? So it got the config map, mounted. So which is nice. But there's another error. Let me help you guys. It doesn't tell much because
maybe you get the logs.
Yeah, the logs.
Oh, gee, I forgot that. Oh, yeah,
QCTL
sorry.
logs.
Like that's the procedure, right? You do a describe, and if there's nothing in the events section, then you look at the logs.
See, I got I did the same thing today. I had a typo in the while I was getting the command from the book. So it says there is a problem with this configuration. Then I checked to see that the max memory policy should have a dash here, whereas mine doesn't. So you need to feed the right configuration into your, obviously, container. So let's see if this is going to change, because I need to recreate the config map.
Yeah, it should be max memory dash policy.
Yes, but
I
typed it like this first,
yep.
Which happens in the exam all the time. Like you can miss things here and there. So you might need to, yes, look into the pods or containers, why things are not working. So yeah, delete, or just let's see if I can write on top of it. Let's try this one as well.
You can on the exam you can copy and paste from the question field as well.
Yeah, very important.
I would actually recommend people do that because the names can get quite long.
Yeah, do not try to type everything that is in the question section, or
especially the context at the beginning of the question. Make sure you're on the right one. And never type it.
Yeah.
Yeah.
And let's see what my pod is doing. Oh, that. Yep, running. So once I reconfigured the config map, it didn't have to be restarted.
Why is that? That's a good question. Why is it that? Some pods you have to restart it. This pod you didn't have to recreate it. Why this one works?
Why, for example, the first one, the mounting, had to be restarted. You also said it shouldn't have to, right?
You don't have to. If the container, because the thing is, you're doing a volume mount. So the process, the container could be like my Node.js application or Redis, and you're mounting the information from the config map or secret. So it's sitting in a folder. So Redis read the configuration from the folder and said like, boop, is wrong, error, and it exit. But then you updated the config map, and that updated the file to the fixed file in the folder. Now it's up to the process to see if it's going to go back and check on that file, or it's watching for that file being changed to reread that file and then get the new configuration. So it looks like Redis is doing that. It's watching the config file. When it changes, it takes the new configuration, and that's how it works. Most applications that people develop right out of the box doesn't have that feature, watching a file. So there's a second process to do that. But this is the reason that the answer is not you always have to replace it. It depends on the application reading the files from the mounting folder. If that makes sense.
Yeah, thank you. So now we can actually check if Redis is using this configuration here. To check this, I'm going to, oops.
You're missing the TTY if you want the output back. The IT.
Oh, yeah.
If T, you TTY, but IT if you want interactive. So
So there's a typo I just came across in the book. This, I think, Chad will edit.
Dash, yeah.
Narrata, yeah. So let's see. How do we check it? Type in config. We need to, get max memory. So yes, it's 2 megabytes, and get max memory dash policy. If I could type, and it's how we describe that. So I think that was a great exercise and example. Also fun to do some troubleshooting with. Now moving on to secrets. They're similar to config maps, but they store obviously secret data. So it's with a base 64 encryption stored in Kubernetes. That won't be enough for your real world examples, guys. So you would need a secret store. Try external secrets operator. And you would need a secret store and a way to connect to it in real world. But for the exam purposes, you would need a vault. But let's create this nice secret again using the create secret command. There's just one little typo again. I let Chad know. Oops. So this is your password and username, right? So this secret, let's check if this secret is created. Get wait, I just used dry YAML. Sorry, dry run. It's here. So now, as you can see, it's not the username and the password is not flat text anymore.
It's encrypted.
It's encrypted.
With base 64 encryption cipher.
Obfuscate.
I was waiting for Eric to say something.
Smack you through the...
No, I'm going to use this YAML and created my secret. I'm getting notes from the sleepover kids.
Oh, if you have to go, Sebi, that's okay. We can stop.
Patch! There's Patch. Sorry, I got
this. Patch reacting to Carlos' comment. He's about to hit
Patch is just having a seizure now.
There's Moby reacting to your Podman comment.
I have Patch's little friend, other Patch.
Sorry, I've totally sidetracked you.
So where are the candies?
Okay, you won't get the candies until I sign off. So
wait, showing their toys, so I'll show mine then.
Okay, show us toys. Oh,
go ahead.
Okay, dev login. So let's check how this looks. You can always use the describe and the type of the resource, which is a secret in our case. So yeah, that's your secret. And it just shows you how many bytes these are. Now we're going to use this in application. Okay, I kind of enjoy now this one is a bit care if things fail. So now we need to mount our secret. Mount our volume, and through that our secret into the pod. This would be a secret volume type, as you can see here.
Similar as the config map. Yeah.
Yeah. Okay, I don't want to type it now.
Since we already did the volume, did the volume example, maybe it'd be more helpful for others to go through the environment variable instead of the volume mount, because there's two ways that you can use config maps and secrets in your pods, right? You can mount them, or you can pass them as environment variables to the container.
Mm-hmm. Should I run this? This would create our pod to use the devlog and secret, very secret username and pass. And I can get it out of the pod, which is the dangerous part anyway. So I can use through this, getting to this directory where I mounted it.
I see.
I can actually get it out, but I couldn't because of this. Yeah.
Yeah.
So it's dangerous. But you would see these type of questions in the exam. And also, you can, that's what you meant, pod chat. I just kept going with the sample here. So then you could pass secrets using environment variables. Let's try running this one. Okay. This will create a secret environment YAML. Let's have a look. Yeah, so with an env, like under the env section, you could pass your environment variables. And this will, oh, wait. I have to add this. Do you want me to? Yeah. Env name dev user. So we're going to pass this.
So it'd be fun to see the two ways in which you can view the environment variables, right?
Sorry, can you say that again? I missed it.
It'd be fun to see the two different ways that you can retrieve the environment variables. Both through you can look at the logs, kubectl logs, or you can exec into the container.
Yeah, you didn't provide the copy YAML for this. It would be useful from the book to copy.
Yeah, right. Yeah, some sections have the copy.
Yeah, but this one you have to type it in everything.
Yeah.
Chad.
As this is an image, it's just taking a bit time, but I don't know.
It's difficult to do. Yeah. So I think the for config maps and secrets, you can mount also, like you can also read, like if you don't know the keys, you can mount, like you can take all the keys from a config map or secret by saying give me all the keys, or you can be picky, like this one, secret key ref, like, no, I want this key and that key only if the config map or secret has a lot of things. And you can do it from both. And in the docs, if you look for config map, there's like 2 pages, one for config map, one for secret. It has all the combinations in there in the docs for the exam. However, but eventually will be like 3 ways that potentially will ask you how to connect the secret config map to a pod, either like load them all to environment variables, load specific ones, or load them as volumes.
I'm trying to find ways to not type it.
Value from, yeah. And it's secret key ref, and then the counterpart when using config map is config map, I think key ref. But the thing is, use the docs and copy paste the example from the docs.
Ooh, I got this a bit.
And it will be a specific folder, right?
Yeah.
Yeah, the file in the host, or in the host, right?
On the jump host, yeah.
Yeah, okay. I had 2 image, names in there. Wait, why? Okay, let's see. Dev login, was it? And user, a password.
Yeah, you can do one. Don't do the other one.
Okay. Let's see.
Well, change line 13 to dev pass. Yeah, remove dev user, just dev pass.
Oops. Okay. This is a pod. Let's see. Get would be helpful. So I can
the logs, right?
Yeah. Logs. That's it.
The app is running.
We have a,
I don't think it's that one. It's secret EMV.
Yeah,
One is 13 seconds ago.
Yeah.
There we go.
Got the secret.
Yeah. So talking about, I think to conclude, talking about base64 in secrets, we have config maps and we have secrets. I have a question for the folks who are still here. Why do we need a secret resource? Why can't we just have config maps and then people don't have to argue or like do stuff with secrets or config map secrets? Just have config maps, and if you have something like a binary file, you can base64 and save the base64 in a config map. So why do we have secrets? It's a legitimate question. I don't know why. Because you can do everything with config maps, right?
It's a concept.
Times in.
Go ahead, Eric. Is there more security one, right? So go ahead, Eric. Security SME.
Of course.
Well, I mean, the main thing is that you can RBAC it, right? It's a separate entity. So you can apply separate RBAC so only the service accounts that need them can get to them, as opposed to the config maps, which you could have separately. They're not secret type information. But they also have types that you can have, like certs, image, Docker, registry types, things like that.
Yeah, I think it's more of a user experience.
Yeah, I
Because
think
having everyone to take all these concepts that are a little bit different from config map and stuff them, because you can put a type in config map, you can stuff the base64, but with that user experience, you're probably going to have it wrong sometimes, and you're dealing with sensitive information, right? Or even permissions, as you said, the RBAC of like, I'm okay to show you the config, but I'm not okay to show you the secret, right? Part of the app. So good. You earned a cookie, Eric. Yeah.
A lot of folks don't use them for application secrets at all. They still use a direct access to Vault or whatever they use.
Yep.
Because they don't want that. Because even if you use a secret, it's still going to be visible to the process in some way, because it has to get it through an environmental variable or a file. So having that in a Arc or Vault or whatever, CyberArk, is still what a lot of shops like to do.
Yeah, you have to dump it, but the process will have it, right? You will have it in memory. So,
yeah, eventually somebody has to have that.
yeah, somebody needs to have that token. But yeah, there's multiple ways. Like Sevi said, external secret operators is a way to connect to get the sensitive information connected and put it in, but you would be putting it in etcd. Some end users don't want to ever secrets to touch etcd. Some are okay because they use something like a encryption device on the hardware, right? That those etcds are encrypted on hardware. You can encrypt etcd secrets, like that's something from upstream. And also you have like the open source CSI secret driver. We have it in AWS, and other vendors have it. That is, you tell the pod, hey, mount. You create something that says the pod will mount this. I want this secret, and then the kubelet is in charge of talking to the backend, to Vault or a secret manager, whatever, gets the sensitive information and do the mounts. So it never in TMPFS, temporary file system. So it never actually touch a disk, an SSD, or this is in memory volume. Go ahead, chat. Yeah, something about volumes in containers.
Yeah, so Matthias, sorry if I'm pronouncing that wrong, said, is this from init container? I'm not sure if that was an old.
Oh, for Vault, maybe.
Question,
so in Vault, you have different ways of getting that sensitive information. So the CSI driver, no. CSI driver is just kubelet and the pod working together to get that information. The one that Eric was mentioning, there's different ways of getting the Vault agent to get the sensitive information, get it to you. So one is like init container that you can mutate or add to your pod, that it will grab the sensitive information, put it in empty there somewhere, that then the other container grabs, sidecar pattern, or is a sidecar that always runs, that is there, and it fetches like every 8 hours or every 4 hours, like, because you can rotate secrets and then get the new versions, and then that your app is connected to that sidecar and gets the secrets from the sidecar, the Vault, called the Vault agent, right? I think.
There's speaking earlier, you mentioned TGIK, the old YouTube channel we used to watch all the time. Josh Rossa has a really good talk from 2 years ago on secrets, Kubernetes secrets management, and how to encrypt the etcd back if you're going to do that, and the rights and wrong ways. And I think it was right around the time CSI secrets were starting to come out, the CSI provider, but mentioned sealed secrets and other things like that.
Oh, Chad, you covered that, encrypting etcd or encrypting secrets?
I don't think that's in the CKA. I think that might be
CKS.
CKAD is the.
CKAD.
It would talk about sealed secrets maybe, but it wouldn't talk about the doing a KMS on the actual etcd secret store.
Oh no, I mean the question. I think the question is related to like go to Kube API, control plane, and configure it to now start encrypting any new secrets, and then asking you for the secrets that are not encrypted in etcd, re-encrypt them. Maybe it's a CKS question.
I think that might be a CKS.
Yeah.
That's more of an operational concern.
I know that changing the encryption configuration is on the CKAD.
Really?
Really? I don't
Or,
remember.
I'll have to look at that. Interesting.
Okay. It's more.
Yeah.
It's better for CKA than CKAD, right?
Yeah, I agree.
Okay. I think we're the only ones here. Matthew is hanging out, I guess.
We're killing
Matthews.
people.
So this will be a long recording, but whoever is watching online and studying for the CKA, watch the recording and join the Slack if you have questions. So we're going to end up here. Thank you, Sevi. I know you were having like visitors in your house and all that, and it took longer than we usually have, but I wanted to give you the opportunity to show all the Easter eggs that you had. So thank you so much. You did great.
Yeah, thanks for bearing with me, because it literally has been it's been a while since I actually haven't done basics, and yeah, I really enjoyed it, and yeah, I really need to get my CKA as well. So this book club is super nice right now for me to just polish.
Who's got next week?
I think I can do next week, or if you want to do the next week, we can flip a coin.
I think I had drawn the straw for connectivity or networking or whatever that chapter.
Okay, yeah, I can do next week. Running
the week after is mine, as far as I remember.
I'll stop the recording here for folks watching.
Yes.